So now we will discuss about the register organization in 8086, register organization in 8086 microprocessor. So totally we have 14 registers. Okay, total we have 14 registers. That 14 registers will be divided into 6 groups. Okay, sorry, 5 groups. So first one is a general registers, index registers, segment registers, and pointer register, and last one is a flag or status registers. Okay, general registers are divided having 4, okay, 4 registers: auxiliary, accumulator, next base register, next counter register, and data register. Okay, and next let we discuss it in detail about these registers. So accumulator, so the accumulator is an 16-bit accumulator. Actually these are all are 16-bit registers. Okay, we can use either 16-bit register or else 8-bit register. So that's why it have a H or and a L, that is a higher and lower. L for a lower and H for the higher byte. Okay, so totally we have 16 bits. Okay, 16 bits. Okay, and next it is a default storage device. Okay, and next one is a base register, that is BX. It is also a 16-bit register, but BL indicates the lower 8 bits, and okay, BH and BL. Okay, BL indicates the lower and BH is indicates as a higher bytes. Okay, that is used to addresses of the register for the physical addresses in case of certain addressing modes. Okay, for example, indexed or in register indirect addressing modes. Next one is a counter register. So counter register also CH and CL, so lower and higher. Okay, it is used to difficult counter in case of the string and loop instructions. Okay, or else it can be used in a string counter in a string manipulations. Okay, either a shift or rotate or instructions. Okay, next one is a data registers. So data register is a general purpose register. So this can be used as a port numbers in IO operations. Okay, and next coming to the index registers. So index registers is divided into the two parts. First one is a source index and destination index. Source index is a 16-bit register. Okay, source index is a 16-bit register. This register used to source index. Source index register is used to point the memory locations in the data segment. Okay, next one is a destination index. So destination index, that is a DI. So it performs the same function as a SI. Okay, it can. Okay, next one coming to the segments. Okay, segment registers. Segment registers are 4. First one is a code segment. So code segment is a 16-bit that is used to addressing memory location in code segments of the memory. In each memory will be divided into 64. It occupies a 64 KB. Every memory segment will be these segments are occupied with 64 kilobytes of memory in memory locations. Okay, so the this one is cannot directly change it. Okay, the CS register cannot be changed directly. So the CS register is automatically updated during for jump, for call, or for return instructions. Okay, next one is a data segment. So data segment is also a 16-bit register that points a data segment of the memory where the program data is stored. Okay, and it can change directly using the POP or LDS instructions. Okay, next one is a stack segment. So it is also a 16-bit register and used to addressing the stack segment address. Okay, this register can also be changed directly using the pop instructions, pop and push instructions. Next one is ES is the extra segment. So it is also the 16-bit register, and it points a data segment of the memory where the program data is stored. Okay, and this also changed directly by using the pop or LES instructions. Okay, coming to the next one is pointer registers. So the pointer registers is three types. So first one is instruction pointer. So the instruction pointer is the same as program counter in case of 8085. So it also having the it holds the address of the next instruction to be fetched from the memory. It contains an offset of the next word of the instruction code that instead of its actual address. Okay, and next same as a program counter in 8085, okay, which holds the address of the next instruction which is going to be executed. Okay, and next one, base pointer, that is BP. BP is also the points the same. It is a similar base pointer and stack pointer are both are the same. It can point the stack segments. Both are points the stack segments, but the difference between the stack pointer and base pointer is stack pointer can only stores the base address of the stack segment, whereas the base pointer, it accesses data in the other segments also. It accesses the data in other segments also. And the next one is flag registers. So the flag register is having the 16-bit. In 16-bit only 9 bits are used. In 9 bits there are these 9 bits are divided into the two types. One is a conditional flags. Okay, first one is a conditional flag and second one is a control flag. Okay, control and a conditional flag. So already we know 5 flags of 8086, the same as which is in 8085. So 5 flags are same as 8085. So carry flag, parity flag, auxiliary carry flag, zero flag, sign flag. Okay, what is a carry flag? Carry flag, when it will be set? So it sets when the carry flag can set when the last most significant bit can carry the can generate the carry. It will be set, otherwise it is reset. Parity flag, the result, the complete result, if you are having even number of ones, it will be 1, otherwise it will be reset, that is 0. And auxiliary carry, the third bit can generated carry to the fourth bit, then it will be set, otherwise it will be reset. And coming to zero flag, so zero flag is nothing but a, if the result any arithmetical operation, if the result will be a 0, then it will set the zero flag, otherwise it will be reset. Next is sign flag, if the most significant bit having result the most significant bit having if 0, it will be positive. If it having the most significant bit 1, then it will be negative, right? So next, these 5 bits or these 5 are conditional flags. Remaining bits or control flags. Okay, sign flag, zero flag, auxiliary carry flag, parity flag, carry flag, these are all belongs to the conditional flags. And overflow is overflow is also belongs to the conditional flag, because if the result is extended of the most significant bit, then it will overflow flag is set, otherwise it will be reset. So this one also includes to the conditional flag. And remaining remaining, that is DF, IF and TF, these three or belongs to the control flag. So TF is the Okay, TF is a trap flag. Okay, it is used for single step control. Okay, used for the single step of control. If this flag is set, the program can be run in single step mode. Okay, otherwise it will be reset. And next one is IF is nothing but an interrupt flag. So if there is an occurred interrupt, then it will be enable. That is 1. Otherwise it will be reset. That is 0. And next one is a direct flag. So direct flag is used in a string operations. Okay, it will be used in string operations. If it is set, the string bytes are accessed from higher memory to lower memory. If it is 0, it will be accessed lower memory to higher memory. Okay, so this is about 8085 and registered organization of the 8085. Okay, bye.